Welcome back, everybody. In this video, we'll be doing section 1.3, and that'll wrap up chapter 1 for us. Like the last couple of sections, this one is kind of vocabulary heavy and not really any calculation in it. And as there's definitions as before, but again, you don't need to memorize definitions. You want to instead aim kind of for conceptual understanding. So let's get started. The section is collecting sample data. So first thing is a definition of what is called an observational study and then also an experiment. So the definitions are as shown here. An observational study. In an observational study, we observe and measure specific characteristics, but there's no attempt to modify the subjects under study. In contrast, for an experiment, some treatment is applied, then the effects of the treatment on the subject are observed. So an example of an observational study would be doing things like collecting shopper demographics at a store you're running. Just collecting information about something that is already there, it already exists, and you're not trying to change anything. An example of an experiment would be where you measure people's performance on like a task and then give some sort of review or remediation or training to them, and then have them take a follow-up test to test the skills. For example, let's say that you are a sales manager and you're in charge of a bunch of salespeople. You could take a look at their sales figures for the last 6 months and then have the salespeople who work for you go through a 6-week training. And then after that, take a look and see if their sales records improve after having completed the training. Okay, so that would be an example of an experiment. The word experiment here has a little bit different of a meaning than it would have in like a science class or chemistry class or something where you were playing with chemicals and such. A big difference though, or a big kind of common element there is that you are trying something and seeing what happens in an experiment. An observational study, as the name implies, you're basically just looking and noting what there is. Okay, as examples, suppose that you've done some study and you found that 63% of persons who are polled preferred Honda over Toyotas or something. Okay, that is an example of a result from an observational study. You've just asked people what their preference is. Okay, in a study of 40 salespeople, 20 attended a training seminar, as I mentioned, something like that. Then the 40 salespeople's sales figures are studied over the following year. So we would check basically the before and after and see if there was an improvement to see what the efficacy of the training was. Okay, as a general note, experiments are often better or more useful than observational studies because well-planned experiments can reduce the chance of having the results affected by what's called a lurking variable. A lurking variable is lurking means basically like hiding in the shadows, right? A lurking variable is one that affects the variables included in the study, but is not actually part of the study itself. Okay. A lot of the procedures that we do or will perform in statistics depends on our sample being collected as a simple random sample. And for the most part, we're approaching this course that you are going to be consumers of statistics. That is, you'll be reading statistics produced by other people. And those people will probably have conducted the polls or surveys correctly and given you the results. But it's important still to know some of the basics, including what a simple random sample is. For the most part, for our course, we're going to assume that whatever tests we do at a later date, we're going to assume that the requirements are met, such as having a simple random sample. But we should talk about what it is. So that's a bit of a complicated definition, so let's take a look at it carefully. A simple random sample of n subjects selected in such a way that every possible sample of the same size n has the same chance of being chosen. Okay, so pick a particular value of n, like 20. If any sample of size 20, of whatever it is equally likely to be chosen, then it is a simple random sample. And if not, it isn't. Okay, so to give a concrete example, let's say that we're interested in finding out how many units the typical COD student is taking. And so we want to poll groups of 30 students, okay, to find out how many units the students are taking. So if we want to go into COD's computers and randomly generate student ID numbers and have the computer check for us 30 students, any group of 30 students is equally likely to be selected, okay? If instead we were to choose a course, okay, and say, okay, well, let's take all the 30 students in that course or all the students in this other course or some other course, that wouldn't be an example of a simple random sample because not every possible group of 30 students is equally likely to be selected. In the first case, where the computer generated just 30 student ID numbers, and we were going to check those 30 students, then any group of 30 COD students is equally likely to be selected. If instead we just pick 30 students in a particular course, like let's say this course, Math 14, or some other course, some history course or a CIS course or something, not every group of 30 students at COD is equally likely to be selected. That would make it not a simple random sample. Okay, the distinction between simple random samples and ones that are not so important in this textbook, as I mentioned, we're going to pretty much assume that simple random sampling has been performed when necessary. Okay, an important thing, in a simple random sample, each individual is equally likely to be selected. That's in a random sample. Is any sample of a given size equally likely to be selected? If so, then it is a simple random sample. Okay, so more terminology. Out of all the different kinds of sampling you can do, and there's whole courses devoted to sampling. If you decide to take a major in statistics, you'll take one class, whole class that's just about sampling. Lots of different ways of doing sampling. So let's take a look at each. Systematic sampling, that would be taking some starting point and then selecting every kth, like every 50th element in that population until we get a sample of the correct size. An example would be, let's say that you work at a factory that makes toasters or something, and you wanted to collect a sample of 10 toasters and test them for defects. So you don't want to pick the first 10 toasters of the day or the last 10 toasters. You don't want to get the workers especially tired or anything like that. You want a random sample. So we might say, let's take the third toaster that's produced, and then after that, we'll take every 25th toaster that comes afterwards. So the third, the 28th, and then 28 plus 25, 53, every 25th toaster afterwards. Let's say that would give us a systematic sample. Okay, another example of systematic sampling. Let's say that you want to poll people coming out of Walmart or something and ask them what their favorite food is. Okay, if you want to take and find a sample of 50 people, you can say, okay, let me just ask this person right here, and then I'm going to ask every 10th person who comes out. Okay, instead of all the first 100 people, just say every 10th person. Okay, that's an example of systematic sampling. In convenience sampling, we simply use results that are very easy to get. So if you're, again, outside Walmart, you want to ask and find out what people's favorite foods are, just ask people who seem like they're friendly, okay? People who it seems like it would be easy to ask them, okay? Stratified sampling and cluster sampling are two types of sampling that are easily confused. People get easily mixed up between the two, so we'll try to be careful about those. In stratified sampling, we subdivide the population into at least two different subgroups called strata, so that the subjects within the same subgroup share the same characteristics, such as age bracket or major in the case of students, or eye color, or some other feature. Okay, then we draw a sample from each of those subgroups. Okay, cluster sampling, we divide the whole population area into sections or clusters, and then randomly select some of those clusters and choose all the members from those clusters. right, so here are some graphics that kind of hopefully illustrate the different types of sampling. Simple random sample is described such that every sample of the same size n is equally likely to be selected. Systematic sampling, every kth subject here, every third car coming off of an assembly line, the third, the sixth, the ninth, and so on. Convenience sampling, using data that is easy to get. Again, cluster sampling and stratified sampling easily confused. For stratified sampling, you're dividing the entire population into groups according to strata. In the illustration here, it's men and women. And then a sample is taken from each of those groups. So here, 3 men and 3 women are chosen. For cluster sampling, the whole population is partitioned into clusters, geographically often. And then we select all the members of the selected clusters. Okay, so an example, again, taken from students. Let's say that we wanted to know how many Math 14 students actually bought the textbook. Okay, how many bought a physical textbook versus just getting my math lab and then the ebook? So if we wanted to do stratified sampling, then we could take all the different sections of Math 14, my class, and then Professor McJilton's class and Professor Bartle's classes, take all the different classes, and then we'll ask 4 students from each of our classes. Okay, that would be an example of stratified sampling. There we've divided all the students into groups according to the characteristics, which is basically which class they belong to, and then taken some from each group. Okay, if instead we were to do cluster sampling, we might have the whole population, that is again all the Math 14 students, divided into groups. Here they're divided into groups according to what class they're in, and then you might choose 3 whole sections at random to survey. So maybe all of my students and then all of Professor Bartle's the students. Okay, there we would be taking a couple of specific clusters and polling all of the students within those clusters. Okay, a little bit more words. Okay, then we talked about observational studies versus experiments. The next couple of terms have to do specifically with observational studies. So cross-sectional, retrospective, and prospective studies. A cross-sectional study, data are observed, measured, and collected at one point in time, not over a period of time. These are kind of commonly seen if you are polling people coming out of a store. That would be probably the easiest example to think of. Data are collected, measured, and observed, collected, and measured at one point in time, not over a period of time. Both retrospective and prospective studies are taken over time. In retrospective studies or case control studies, data are collected from past time periods, going back in time by examining records, interviews, and so on. So basically looking backward, that would be retrospective studies. Prospective studies, data are collected in the future from groups that share common factors. So we might give a bunch of students in the first grade now a proficiency test of some sort, and then see how they do on exams in middle school and then high school, and then see what their ultimate goals are in college. And that would be an example of a prospective study because it is looking forward. Okay, an example of a retrospective or case control study. There we might look at groups of people who had some sort of disease, some sort of lung disease or something. We might look back and see, how many of them smoked and over what period of time, and what other kind of past history they'd had that would have affected them. Okay, a flow chart here can help you decide what kind of observational study you are looking at. In an observational study, again, you're observing and measuring, but you're not trying to modify, train, or cure or change anything. So there's no modification. So the decision is based on when the observation are made. Is it in the past at one point in time, or is it going forward? For a past period, it would be retrospective. At one point in time, it's cross-sectional, and then going forward in time, it is prospective. Okay, a little bit about experiments next, and then we'll be finished. Uh, in an experiment, confounding can occur if we see some effect, but we can't identify the specific factor that caused it. And a lot of times, if you are more careful about the way the sampling is done, that can decrease the amount of confounding that can occur. For an example of a bad experimental design, suppose that we're going to do a treatment of some sort. We want to check and see if this new headache medication works well, let's say. And so we've got a bunch of test subjects we're going to give this headache medicine to. We're going to give the actual medicine to all the women. We'll give placebos to all the men. This is a bad experimental design because if we decide that the medicine is effective or not, we won't know for sure whether it's because the medicine is actually effective or maybe it just works on women and not men. Instead, it will be better to have some of each, right, within the groups. Okay, a completely randomized experimental design instead treats these randomly selected subjects and gives the others a placebo. So basically everybody is just mixed, and then some people are randomly chosen and given the medicine, some people are randomly chosen and given the placebo. Okay. A randomized block design. We have a block of men and a block of women, and then within each group, a subset is chosen and subjects are treated within each block. Okay, in a matched pair design, measurements from the same subjects are taken before and after some treatment. So we check and measure how many migraines a group of people get per month, and then we give them some treatment, and then we measure the same subjects after the treatment and see how many migraines per month they are getting. So it's the same subjects in each case, but we're measuring the incidence of their migraines both before and after treatment. All right, so that takes us finally to the end of chapter 1. There was a lot of vocabulary there. Try not to get too bogged down in, like I said, all the definitions that are here. Try the homeworks, the assignments that are on my math lab, and that will help clear up some of the possible confusion that there is. We'll be getting started on chapter 2 soon, and that will be a little bit more tangible probably because there's more calculation and more that feels familiar in it. So in the meantime, let me know if you have any questions, and have a great day.